Hi guys, welcome to this session on space. So this is P8. This is only for triple science, the separate sciences, the AQA course. This session, what I wanted to do was just go through some of the basics for the space topic, some of the key words. It's quite a small topic, so there's not really that much you need to know about it. The main thing is going to be in a few sessions' time on things like stars. So what we're going to do today is we're going to look at things like the keywords in space topic. A lot of these things you probably would have covered in things like year 7, but we're going to go over it again. So to start off with, this is a solar system. This is our solar system, a very simplified version of it. In real life, these circles or orbits would be more elliptical, i.e. the more squash circles. So this is a solar system. A solar system is where you have a star or stars with planets orbiting them. So in our solar system, we have our star at the center, which is the sun. And then orbiting them, we have the 8 planets. It used to be 9, but Pluto is no longer classed as a planet anymore. So these are the planets in order, going from closest to furthest away from the sun. You have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. You also then have Pluto, and you have other objects. So let's define what a planet is to start with. So a planet is a body that orbits the sun. I mean, to define a planet, they need to do 3 things. One is that they need to be large enough so that they are spherical. So the larger they are, the more gravity they have, the more spherical they should be. Second thing is that they need to orbit a star, so we orbit the sun. And the third thing is that the area around it needs to be relatively clear. So if you look at something like the Earth, we're relatively clear. The only thing really around us is the moon. But if you go to somewhere like Pluto, Pluto is actually in something called an asteroid belt. It's called the Kuiper Belt. It's also classified as something called a trans-Neptunian object. So i.e. beyond Neptune, there is an asteroid belt, lots and lots of very small rocks. I say small, I mean they can range from a couple of kilometers across. Nevertheless though, because Pluto is in that, the area around it is not clear. If anything, there are objects bigger than Pluto there. So this is where they said Pluto is no longer a planet. You need a way of remembering the order of these planets. Go with the very easy mnemonic of my very easy method, just speeds up naming. Doesn't need to be complicated. Make it funny, make it rude if you want. I'm not going to give you any rude ideas, but funnier and ruder it is, more easily remember it. So those are the planets, and they orbit a star. So if we look at what a star is, the sun is our star that we orbit in our solar system. A star is a body of gas, can be some rock as well, but different elements in there, mainly gas. And what it does is it converts smaller elements, it combines them together to make larger elements in a process called nuclear fusion, which we cover in P6. So fusion is where you take smaller elements and you combine them together to make larger elements, and they release energy because they convert mass into energy. So what our sun is doing is it's currently converting hydrogen into helium. And the mass is being converted into energy, and this energy is taken in the form of things like light, heat, and other electromagnetic radiation. So a star is a gassy body that gives out radiation in the form of light and heat and other electromagnetic radiation via the process of fusion. So if we go a bit closer and we talk about our planet maybe in particular, we can talk about things like moons. So what is a moon? Well, a moon is a rock that orbits a planet. It's also defined as something called a satellite, or in this case, a natural satellite. So a satellite, you probably think of the more artificial satellites when we talk about this. A satellite is an object that orbits another larger object. A natural satellite is an object that orbits another larger object that is not man-made, i.e. something like the moon. So when we talk about things like, I don't know, a communication satellite, that is more an artificial satellite. So how are these things in orbit? Well, it's the force of gravity. Gravity keeps things in orbit with each other. So the reason why the sun is orbited by planets, and the reason why the moon goes around the Earth and other satellites orbit other planets is due to gravity. Gravity is a force created by mass. So if you have mass, you have gravity. It's very weird to think that if you have 2 people in the same room, they are literally attracted to each other via gravity because they both have mass. It's just on a small scale like that. The force of gravity is so weak you wouldn't notice it. But where you've got something like the moon and the Earth, where the gravity is substantial, I'm talking about the mass of the Earth is about times 10 to the 24 kilograms, the gravity caused by it is massive. And then you've got something like the Sun, which is 1,000,000 times heavier than the Earth. The gravity is a lot stronger than the Sun, hence why the planets orbit the Sun. Wow. Right. So if we look at some different objects in the solar system and objects in space, we have these things. So these things are called asteroids. So asteroids, you normally see them in a belt. If you look really closely in this diagram, you can see that belt there. The belt is between Mars and Jupiter. When the solar system was created, we believe that these rocks sort of were attracted to the large gravitational field strength caused by Jupiter, hence why they're there. So these rocks orbit in a belt. They're quite small across, relatively speaking. I mean, again, some of them can be a couple of hundred meters, kilometers, but compared to things like planets and the Sun, they are relatively small. And what they do is these small rocks, they orbit around the Sun in this belt. And what I mentioned earlier is that beyond Neptune, there is also another asteroid belt called the Kuiper Belt. Now, sometimes what these asteroids can do, because of their sort of random nature, is they can bash into each other. You know, all they're doing is they're orbiting around, they can collide into each other, and if they collide into each other and they've got enough momentum, they can escape their belt orbit. And when they escape their belt orbit, they can just fly off into space. They may be attracted then by the gravitational field of another planet or a star. Sometimes what happens is they can come close to Earth. And if they come close to Earth, the gravitational field of Earth can attract them, can cause them to attract them into Earth itself. And when they come towards Earth, this is a bit more of a science fiction thing that people are thinking of. When they come towards Earth, you will see them burning up in the atmosphere. When they start getting closer to the planet and they start colliding with the gas particles that make up the atmosphere, these collisions transfer energy, causing the rocks to heat up. And some of them can burn up. If they're small enough, these rocks that enter our atmosphere, they burn up straight away. We normally see these as a shooting star. So that is what they call a meteor. So a meteor is an asteroid that's been knocked out of its belt that enters Earth's atmosphere but doesn't reach the Earth's surface because it's burnt up by the atmosphere. But if you have an asteroid that is large enough, as it comes towards Earth's surface, it will start to burn up and it will start to break up. But because it's so big, it might actually be large enough to hit Earth's surface because not all of it has been burnt up by the atmosphere. And they call that a meteorite. So that's what strikes the surface of Earth. So for example, this is a meteorite, and if you look at it, you can see that the outside is melted, and that's because the atmosphere, as the meteorite is colliding with the atmosphere, it starts to heat up and it will start to melt the substance, especially if it's something made of metal. Now, you can also get this thing called a comet. You may have heard of comets before. Comets, the best way to describe a comet is a dirty snowball. So it's basically a chunk of ice and rock. And what these things do is they orbit the Sun. Now, they don't orbit it like the other planets do. So if we go back to this picture of the other planets, and even this isn't accurate, when a comet orbits a star or the Sun, what it does, it orbits in a very weird shaped orbit like this. It's called an ellipse. Now this ellipse is a squash circle. It's very elongated, high in eccentricity. At one point of the orbit, it's very close to the Sun. Another point of the orbit, it's very far away from the Sun. And this isn't to scale. The orbit needs to be exaggerated even further out this way. But what happens is that the comet will orbit the Sun in this orbit, as I've said here, and as it gets closer to the Sun, what will happen is it will actually start to heat up as it gets close towards the Sun, and that will cause this dirty snowball to start melting. And as it melts, the water vapor, the water liquid, and things like rocks will start to fly off in the other direction. So what you'll get produced is this tail that you hear of a comet. So this part here is the comet, and this part here that's coming off is the tail. So it's the melted ice and rock that's coming off the back of the comet. And as it goes around the Sun, the speed of the comet changes. So, for example, somewhere like over here, it would be going quicker than it would be over here because it's close to the Sun, therefore higher gravitational field strength there. And the tail direction also changes direction as well. So sort of more this way and then that way it changes direction, well, that way, as it goes around the sun. Comets, if they come close to the Earth, relatively speaking close, and it starts to heat up, these rocks might enter the Earth's atmosphere, and so therefore what you've got is a lot of meteors all at once coming into the Earth's atmosphere. They'll start to burn up, and this is where we get a meteor shower. So lots of rocks entering the Earth's atmosphere all at once, and you'll start to see them lighting up the sky like a it is a shooting star essentially. Okay, so some other things, galaxies. So if we zoom out of the solar system and you keep going, you'll start to see other solar systems and you'll start to see other stars around us as well. And this is where we have a galaxy. So a galaxy is a large collection of stars and solar systems, a very large collection. This is our galaxy called the Milky Way, and this is got a spiral galaxy. So it has the center here, and it has these arms that go around it like that. We believe at the center of our star there is something like a black hole, a supermassive black hole with a very high gravitational field strength that all of these galaxies and stars orbit. And if we zoom out even further, you'll start to see other clusters of galaxies as well. And essentially that's everything. If you took everything, space, stars, galaxies, everything all together, that is what we call the universe. So the universe is everything and everything that is in it, everything that's ever existed. So I hope that's been of use. Again, just some brief key details on some of the bodies in space just to get you warmed up for the rest of the space topic. Enjoy and see you next time.